Let's start learning maths together. Do subscribe, share and like our channel and press bell icon to get notification when we post our new videos. Hi friends, in this video we are going to discuss the chapter number systems of 9th syllabus. So let's start with the topic. In this session, the first thing we are going to cover about the real numbers, all the basic things which we have already studied in the previous standard. About the rational numbers, the definition, examples, then some properties of rational numbers. So first one, in real numbers, we are familiar with the number system such as set of natural numbers which begins from 1, 2, 3, 4 up to infinite, and set of natural numbers is denoted by the capital letter N. Next one is set of whole numbers. It begins from 0, 1, 2, 3, 4, 5 so up to infinity. It is denoted by the capital letter W. Next one is set of integers. So it includes all the positive and negative numbers along with 0. It is denoted by capital I or Z. Z means in Germany Zahlen. Zahlen meaning is numbers. Next one is set of rational numbers. All those numbers which are of the form of P by Q, and P and Q are any integers and Q is not equal to 0. Set of rational numbers is denoted by capital letter Q. The relationship of these number sets pictorially represented as shown here. First one is set of rational numbers. It includes the set of integers. That also includes the set of whole numbers, and set of whole numbers includes the set of natural numbers. This is how these four real numbers related to each other. So next we'll discuss about the rational numbers. Definition of rational number is a number that is in the form of P by Q or can be put in the form of P by Q where P and Q are integers. Q is not equal to 0 is called rational number. For example, we can take it 3 by 5 is a rational number, minus 4 by 7 is a rational number, 6 by minus 3 is a rational number. Also, we can consider 2, 3, minus 5, minus 7, 0. These are all the set of rational number. Why? Because these numbers or integers can also be represented in the form of P by Q, because every integer has 1 as its denominator. So that's why. So this is of the form P by Q. So all the set of integers can be represented in the form of rational numbers. So these are some examples of rational numbers. So we also consider here the rational numbers can be expressed in the decimal form as terminating decimal or non-terminating recurring decimals. Now we'll see some properties of rational number. In that first one, every rational number is either a terminating decimal or a repeating decimal. Let's see some examples. In that first one, 3 divided by 5. If 3 divided by 5, then the quotient is 0.6 and the remainder will be 0. That means as we get the remainder as 0, the decimal value is terminating. That means this rational number has the terminating decimal expansion. Let's consider one more example in this. 6 divided by 7. Whenever 6 divided by 7, the quotient appears as 0.857142 0.857142. Here we can observe that after 0.857142 again the same pattern of the number is repeating. So that's why it is called repeating decimal expansion. One more example we can consider 9 by 11. 9 by 11 is also a repeating decimal expansion. The same way, if 5 divided by 8, so if 5 divided by 8, the quotient is 0.625 and the remainder will be 0. That means it is also a terminating decimal expansion. So these are some examples of rational numbers which have terminating decimals and repeating decimal expansions. Next, second property. Two rational numbers a by b and c by d are equal if and only if a into d is equal to b into c. You can remember here we have already learnt about equivalent rational numbers. So this is the same property. Here if we will consider two rational numbers 2 by 3 and 8 by 12, then it implies the cross multiplication of the two rational numbers, that is 2 into 12 is equal to 8 into 3. The product of LHS and RHS is equal, that is 2 into 12 is 24 and 8 into 3 is also 24. That means these two rational numbers are equivalent or equal. The third property, that is the second property, holds good if and only if a into d minus b into c is equal to 0. Therefore, if these two are equal to 0, then a by b is greater than c by d. If and only if a into d minus b into c is greater than 0. And a by b is less than c by d if and only if a into d minus b into c is less than 0. Next, the last property, for any three rational numbers p, q and r, the following properties are true. In that first one, either p is greater than q or q is greater than p or p is equal to q. That means the numerator can be greater than denominator or denominator can be greater than numerator, or both can be equal to each other. Second one is, if p is greater than q and q is greater than r, then p is greater than r. So here let's take one example. If p is equal to 5, q is equal to 3 and r is equal to 2. Here numerically we can observe that p is greater than q and q is greater than r. Then we can state that p is also greater than r. Third one, if p is greater than q, then p plus r is greater than q plus r. So that means for p and q, if we add any constant integer on the both side, then the relationship remains same. Then if p is greater than q and r is greater than 0, then p into q is greater than q into r. That means the product of p and q is always greater than the product of q and r. So these are some properties of rational numbers. So this is all about this session. In next session we can discuss about the irrational numbers, definition of irrational number, their properties and the representation of irrational numbers on number line. So students, let's have some homework for you people. So sitting at home, you can do some homework on today's topic. You can find some equal rational numbers. We have already studied about equal rational number, how to find the equal rational numbers. If LHS and RHS product are equal, then those rational numbers are equal rational number after cross multiplication, we have already discussed. So here you can have that practice at home, find some equal rational numbers and verify all the properties, equivalence properties for those rational numbers. Also verify other properties by taking some examples. One more homework, you can recall the representation of rational number on number line studied in 8th standard. So guys, do like, share and subscribe our channel, and your feedback is most important for us. It encourages us to improve ourselves. So please provide your feedback here. Thank you.
Do subscribe, share and like our channel and press bell icon to get notification when we post our new videos. Thank you.